we are going to talk about really two different kinds of software. Many people put programming environments into system software, but we have what we call system software, which was what we talked about with an operating system. We talked about the Windows operating system. What other operating systems are you familiar with? Linux, Unix, iOS, the Mac. These are all different operating systems that work on the platform. So let me, I don't know if we can see this on the, let me scoot the camera over. Wrong way. Like I said. Okay, so if hardware, of course, anything we do in a computer has to talk to the hardware. We pretty much need an operating system before we use application software. Does that picture make sense to people? So the operating system does what somebody actually discussed quite a bit, which was, I feel like I'm still not seeing this picture. I'm on the wrong side. Hold on, I'm sorry. Technical difficulties. I scooted to the wrong side of the board. I should have somebody here commanding this post. Here we go. Okay. All right, so we have the hardware. Then we have an operating system, which is the system software. And then on top of that can be any type of application software. So application software can be something like Microsoft Office. What is Microsoft Office? What is Microsoft Office? Yes, but what exactly is Microsoft Office? It's a suite of applications. Hold on. I'm really having technical. Let's see. Go back. Just going to keep this here, I think. Microsoft Office includes what? How about that? Let's try that question. What does Microsoft Office include? Yeah. Does include PowerPoint. Microsoft Office is actually called a suite, S-U-I-T-E, of applications because it includes Word, Excel, Access, PowerPoint, Outlook, what am I forgetting? So this is called a suite of applications. These are all very well-known applications, but applications might also be your favorite golf program or some really cool video game that you have. These are all examples of application software. The programs that we write in this class, that's an example of application software. So basically, it's everything else besides system software. Now, we're also going to use a programming environment, and that's what we'll be using in the lab next week. And I'll talk a little bit about that more prior to going in the lab on Wednesday, which, by the way, all labs will be in 303 from now on, okay? So I'm trying to get it fixed on PeopleSoft. It was an error on PeopleSoft. It's still an error on PeopleSoft, but we'll both be in 303, okay? All right, so remember that this class is not per se a programming class. This is a class how to solve problems using software. Now, this process is generally followed by anybody who is going to create a software solution. And we're going to go over this process. It's called the software development lifecycle. Okay? We're going to go over this process, and we're going to talk about where we fit in this process. So the 5 steps of the software development lifecycle begin with defining the problem. Sometimes we call this the analysis stage. I'm going to talk about that for a moment. Our first couple weeks in this class will actually be in this phase. Okay? The second step of the process is designing the solution, or planning, essentially. And this is where we create an algorithm. This is primarily what this entire class is going to be spent doing, okay? Because the third part, the coding or programming, is not really the difficult part. The planning or designing is really where the work comes in. So if we learn how to do that correctly, the coding part is going to be simple, okay? There's also some other very important phases. The fourth phase is called the testing and debugging, and the fifth phase is called maintenance and documentation. So let's talk a little bit about each of these phases. Now, I will mention too, so here I've highlighted on this figure where we are going to be spending our time in this class. We're going to be spending it on the first two phases, the analysis and design. Okay? Notice that this is sort of cyclical. It's not always you do this phase and then you're done and then you go to the next phase. You know, they all kind of, it's called a cycle. So a lot of times you're going back to previous phases in this cycle. Okay? It's not a linear process. It tends to be cyclical. Okay, so step one is the analysis phase. We call this defining the problem. Now, let's say that you have a family business that is like, let's say that you make shoes, okay? And you've been doing this for hundreds of years, and you know you're involved in the business, and you know you'd like to automate this process. A lot of things with the process. Now, you know a lot about making shoes, but what might you not know a lot about? The actual technology and the possible things that you can do to automate your process. So you may hire a company to come in and just basically analyze what you're doing, discuss your needs, maybe come up with some formal process for what all your stakeholders are, what your process is, do a lot of formal diagramming to try to understand what's currently going on and what you would like to have happen. Okay? This phase can be very extensive. It can be millions of dollars, probably not for a shoe company, but for example for something like the space shuttle or some very large project. This phase alone could be a multi-million-dollar project. You haven't solved anything. You're just analyzing what's going on and kind of defining a scope, defining the problem so that it can be solved. Okay? We are going to use a special tool at this phase, and that tool is called an IPO. It's very simple. It stands for Input, Process, Output. Very simple. We'll be creating those in this phase. So we're going to look at a problem, and we're going to come up with a formal way of defining that problem that's going to make it easier for us to solve it. Does that make sense? We're going to pull out the inputs, we're going to pull out the outputs, and we're going to try to define the process steps. Does that make sense to everybody? Okay. But I want to reiterate that this problem can actually be done by an independent contractor who comes in that you may pay hundreds of thousands of dollars to, just to analyze the problem. Does that seem like a big deal? But obviously you can't just solve it unless you really understand the processes. Okay? So that's what we call step one, the analysis phase. Now, one thing to keep in mind, if we look back at this picture, if we don't get the right picture of the problem, what are the chances of getting the right solution at the end? Not very good. So this phase is critical to having a correct solution. Does that make sense? Does that make sense? Okay. Okay, so the second phase, which is where we're going to spend our time this semester, is called the design phase or the planning phase. And this is where we come up with some type of algorithm that is going to have a solution for the problem that was designed in step one. Now, in step one, when you came up with a problem definition, sometimes that is formally called a requirements document. Anybody heard of any of these terms? Okay. So the requirements document may actually be issued, and then you may have several people propose a plan for you, right? And they have a cost associated with that. So you post a requirements document, and then multiple vendors would come up with a plan, have a price and a budget, and all these solutions would be proposed. How would you go about looking at the plans? What would be is there a process? Is anybody familiar with what sometimes you have to do when you're looking at people's proposals for how they plan to solve this problem? You're going to look very specifically to see if it's a reasonable plan. You probably are not going to take which ones? Which plans might you not take? If there's 10 different plans, which ones may raise flags for you? The ones that's the most expensive and the ones that's the least expensive may also throw themselves out because you feel like they don't understand the scope of the problem. So does this make sense? So this can happen on a very large scale or a very small scale, okay? Now, we are going to use, in software, there's two sets of tools that are used. How many people have heard of a flowchart? Flowchart, okay, I think that's my next. Okay, okay. So in software, flowcharts used to be the bomb. You know, everybody walked around with the template, and they drew these flowcharts, and that was cool, and they used the pencils. And the government said you can't write one line of code unless it's been flowcharted. Okay? So let's talk about this flowchart. Okay? So we see at the very top of this flowchart, it says start. And notice we use the same symbol for stop, so that must be a standard. That must be a symbol that everybody uses to begin and end a flowchart. Make sense? Make sense? Now, we have these two blocks, which are both what we call input-output blocks, because in these blocks it indicates we're going to input the pay rate, we're going to input the hours worked, and then we're using the same kind of block when we do what? Output the net pay. So this type of block must be what? An input-output, okay? And on your little plastic template, there's a special block for input-output, okay? This is a processing block, so it has an operation inside it. And then we have these nice lines indicating what happens next and what the flow is. Okay, so what do you think about flowcharts? Pros and cons. Yes? The flowcharts take a lot of time to draw like this. And if something changes, unless you use there are software tools to do this now. So if something changes, then you can simply add it in and move it. But back in the day when you did in pencil, it was really a nightmare if you had to make a change. Okay, what else? Takes a lot of time. Yeah. However, they are visual. And he said there's a good, I'm going to repeat the answer, a good visual representation of the process. There are times where you're trying to explain to somebody how to get to your house, and you're telling them, and what do you finally do? You draw a picture. Sometimes a picture is worth 1,000 words. So they are a clear depiction of what's actually happening in the program. Okay? So they do have some advantages. There's another advantage which nobody's mentioned here, in that each one of these types of blocks is standardized, which means that the whole world agrees that this is an I/O symbol, this is a terminator symbol, this is a process symbol, and that's a good thing. Okay? However, it kind of goes back to the problem of they take a long time. So I call this the food processor problem. You know, you have a food processor, I have one, and you hardly ever use it. So you're going to slice a couple carrots. By the time you get it out, figure out how to use it, you could have sliced 100 carrots, you know, and then you have to clean the thing. So when the tool is no longer helpful and it becomes a hindrance, then it's not a good tool, right? So flowcharts have stated in being used exclusively. However, because they do give a good representation, we oftentimes use it for either complicated areas of code that we want to make sure we agree on, so there's no problems, or, you know, so to indicate what is actually happening in the code. But they're generally not the primary tool, okay? So what we tend to use instead is something called, do I have an example? Oh, well, I have the pseudocode on the other side. Is pseudocode, which is the right-hand, yes, the right-hand side of the slide. So what is pseudocode? What is pseudocode? Informal code writing, not the actual language, but it sort of depicts your steps. Now, the good news is about pseudocode is it's short. It's like making a list. The bad news is that it's not standardized. There are some attempts to standardize pseudocode, but everybody kind of tries to make up their own. Why is it not being standardized a disadvantage? Why is it not being standardized a disadvantage? Yeah, so in other words, you might not agree. I mean, you might use, I've taught this class in the past using only pseudocode. And the students will say, okay, well, shall I use display or print or this or that? I said, yes, they're all okay. Well, when you're first learning, you don't want that. You want to know, what do I type? So in some ways, that total freedom makes it harder to actually, define something that's clear, okay? So pseudocode has its advantages. It's easy to write. It's English-like. It's not standardized, so therefore that makes some people uncomfortable. So in this class, we're kind of going to use C as a standard pseudocode. Does that make sense? So because we're going to pick a language and we're going to say we're going to do it in C, and that's going to be what we use as our design tool, okay? A C-like pseudocode, essentially, okay? So this is just a summary of the differences between flowcharts and pseudocode. Flowcharts are standardized. They're visual. They're difficult to modify, and they typically require special software. Pseudocode can be easily done in the word processor. It does implement structured designs well, but it's not visual, and there's no well-defined standards. There are some standards for this. Okay. Now, our goal is to come up with a set of steps that in step 2, our design. Remember step 2. Step 1 is what? Analysis, defining the problem. Step 2 is design. So our step 2, the goal of step 2 is to come up with some set of steps that any programmer in any language can write the solution for. So when we come up with this algorithm,